morning, everyone. The good news this morning appears to be from ESA that they have received data from the lander and that they're able to trigger all of the experiments as far as I'm aware, and that they are getting data back, or they expect to get data back from that, and that's being looked at. So hopefully we'll get some more information from them in the future to support the electric universe model of comets. But now I want to talk about the sun. If comets are fundamentally an electrical phenomenon, it's telling us something very important about the sun. And it's my contention that most of the mysteries of astronomy can be solved by really understanding the sun. What we have now is a complicated narrative constructed over several centuries that has proven non-predictive in the space age. The noted Australian solar physicist Ron Giovanelli, working at the Mount Stromlo Observatory in the 1940s, and I should say that Mount Stromlo is about 20 minutes from me, and we have somebody in the audience who actually works up there, and so I see him occasionally at the astrophysics seminars. Anyway, Mount Stromlo in the 1940s, Ron Giovanelli concluded that solar flares are basically an electromagnetic phenomenon in which electrons are accelerated by electric fields induced by changing magnetic fields. Now this is the problem that astrophysicists have in separating cause and effect. In 1984 he published Secrets of the Sun, where he writes in the introduction, "Today there are 5 basic problems in solar physics. The first is the sunspot cycle, which is closely interwoven with the second, the structure of the convection zone, which is supposed to occupy about the outer 200,000 kilometres of the solar radius, and with the third, the variation of rotation rate across the surface and with depth. The final 2 are the heating mechanisms in the outer solar layers and the causes of flares. There are many other intriguing problems, but central to almost all is the nature of the sun's magnetic field." That's the end of the quote from his work. In a video prepared before his death in 1985, Giovanelli gently upbraids others for drifting into mathematics and leaving out physics. He continually reminds how little we know about the sun, or to put it differently, how much there is to learn. In the intervening 30 years and incomparably better data from space, things have not improved. They have become worse. Astronomers remain unaware of Hans Alfvén's admonition to first understand the electric circuits of the sun if you want to understand its magnetism. You compare these images of the sun, which we'll just bring up. Compare these images of the sun with a comment by Fred Hoyle in Frontiers of Astronomy, that's back in 1955, where he wrote, "We should expect on the basis of a straightforward calculation that the sun would end itself in a simple and rather prosaic way, that with increasing height above the photosphere, the density of the solar material would decrease quite rapidly until it became pretty well negligible, only 2 or 3 kilometres up. Instead, the atmosphere is a huge bloated envelope. Not only that, the atmosphere extends well out through the planetary system to the heliosphere." Ralph Jurgens in 1980 stated the obvious answer for those not blinded by their training, and you see the quote here. "The modern astrophysical concept that ascribes the sun's energy to the thermonuclear reactions deep in the solar interior is contradicted by nearly every observable aspect of the sun." That was published in 1980. When I read his paper, it just seemed so obvious to me that he was correct. And that was when I began to really try and understand the sun for myself. Ralph Jurgens certainly pointed the way and did a very thorough job. So, what is a star? An undergraduate textbook on the structure and evolution of stars makes a star seem a very simple object. And I quote, "A star can be defined as a body that satisfies two conditions. A, it is bound by self-gravity, and B, it radiates energy supplied by an internal source." Behind this definition are some critical assumptions that Sir Arthur Eddington bequeathed to us long before the space age in his 1926 opus, The Internal Constitution of the Stars. But how many students now read Eddington's original work with a critical eye? Indeed, how many read him at all? Here's Sir Arthur Eddington. Eddington wrote, "The problem of the source of a star's energy will be considered. By a process of exhaustion, we are driven to conclude that the only possible source of a star's energy is subatomic," because at this stage it had been discovered, nuclear energy had been discovered. He said, "Yet it must be confessed that the hypothesis shows little disposition to accommodate itself to the detailed requirements of observation, and a critic might count up a large number of fatal objections." End of quote. A single fatal objection would suffice to falsify the hypothesis, but the apparent isolation of stars in the vacuum of space encouraged the belief that stars must consume themselves to fuel their own fires, rather like a campfire in the sky, only a modern version. The fatal objections would be sorted out later. Two such objections are behind NASA's plan to launch a mission to the Sun called Solar Probe Plus in 2018, with first close approach in December 2024. And I hope I'm about to report on that. NASA says the mission's primary scientific goal is to understand how the Sun's corona is heated and how the solar wind is accelerated. Solar Probe Plus will revolutionise our knowledge of the origin and evolution of the solar wind. That's the end of the quote. That will follow 92 years of denial that there is a serious problem with our understanding of our nearest star. Neither of these features are predicted by the standard solar model. Eddington argued the need for a central fire as follows. "No source of energy is of any avail unless it liberates energy in the deep interior of the star. It is not enough to provide for the external radiation of the star. We must provide for the maintenance of the high internal temperature without which the star would collapse." This is the rationale for having a high energy, high temperature core in a star. But this assumes that a star is basically a ball of hot gas obeying gravity and the standard laboratory gas laws. Eddington's logic of exhaustion had to set aside facts that didn't fit the only possible theory. Appearances can be deceptive when viewed through the lens of a single idea. A kind of tunnel vision develops that accommodates fatal objections with the excuse that someday we will find the answers, just give me more money. To compensate for the weakness of the excuse, those who adopt the consensus view acquire a kind of evangelical zeal, which you can see anytime you see these interviews with astrophysicists. For example, the undergraduate textbook referred to in the last slide opens with, "The theory of stellar structure and evolution is elegant and impressively powerful. Yet we have recently discovered stars that shouldn't exist. In one instance, the star is too huge to be inflated by a central fire." Tunnel vision does more than magnify the elegance of the single idea. It also excludes consideration of other ideas. Alternative ideas are stymied by unquestioning faith in the only possible theory. For this reason, as history shows, most fundamental breakthroughs come from outsiders, those who sit down before facts like a child. Eddington had addressed the problem of generating electricity when trying to explain bright lines in the spectra of some stars. The difficulty is that the heat of the star can't supply the energy of the atoms, producing those bright lines. Something extra is adding energy. He came close to the answer when he wrote, and I quote, If there is no other way out, we may have to suppose that bright line spectra in the stars are produced by electric discharges, similar to those producing bright line spectra in a vacuum tube. End of quote. But he goes on. A disturbed cyclonic state of the atmosphere might establish local and temporary electric fields, thunderstorms, under which the electrons would acquire high speeds. End of quote. Collisions between the high-speed electrons and atoms in the stellar atmosphere would give rise to the bright spectral lines. However, in a footnote, Eddington revealed the fundamental limitation of his theory of stars, and I quote again. The difficulty is to account for the escape of positively charged particles. Unless charges of both signs are leaving the escape is immediately stopped by an electrostatic field. End of quote. This statement will reverberate down the years as one of the gravest mistakes in science. It is an electrostatic model of an isolated, self-contained star. But stellar magnetism is an electrodynamic phenomenon, requiring electric currents flowing in circuits, both within and beyond the star. Birkeland recognised this. Alf Vane insisted on it. A noteworthy outsider had already published an electrical theory of the sun in 1913, long before Eddington's work on the subject. Christian Birkeland, on the left, was a renowned Norwegian scientist and multiple Nobel Prize nominee who set up observatories under great difficulties in the Arctic Circle to study the aurora borealis. His fascinating story can be read in Lucy Jago's biography, The Northern Lights, and I recommend it. His theory that the aurora is due to charged particle beams from the sun has only recently been confirmed, as Don Scott pointed out last night. Birkeland's approach was largely experimental. He managed to reproduce sunspot behaviour, see the inset on the left, in his famous Terrella, or Little Earth experiment, where he applied external electric current in a discharge to a magnetised globe suspended in a near vacuum. Another outsider was Charles Edward Rhodes Bruce, or CER Bruce. He was a Fellow of the Royal Astronomical Society, the Institute of Physics, the Institution of Electrical Engineers, and was a member of the Electrical Research Association from 1924 until his retirement in 1967. His interest in astronomy and research on lightning led him to write in 1968. Perhaps in no scientific discipline other than cosmology have so many theories got by on so little positive evidence. Imagination has had free rein, often at the expense of common sense. The main observational evidence indicating the existence of cosmic electrical discharges is the same as that which would lead an external observer to conclude that lightning flashes occur in our own atmosphere, namely, the sudden change they effect in the spectra and the spectra of the sun, stars and galaxies. In the sun spectrum, lines suddenly appear indicating the existence of gas temperatures of hundreds of thousands or even millions of degrees. That's from his work Electric Fields in Space, published in 1968 in Penguin Science Survey. Here's Sidney Chapman. He was one of the establishment, the British establishment. Sidney Chapman, Fellow of the Royal Society, studied magnetic storms and aurorae, developing theories to explain their relation to the interaction of the Earth's magnetic field with the solar wind. He was recognised as one of the pioneers of mathematical solar terrestrial physics. He continued the tradition of opposition by British scientists to Birkeland's work in Scandinavian science. He disputed and ridiculed the work of Christian Birkeland and Hans Alfvén, but later adopted Birkeland's theories as his own. Near the end of his life, he did acknowledge Charles Bruce in 1964 in a publication called, or a book actually called The Solar Wind. And I quote, "It seems appropriate to call attention to the ideas put forward over many years by Bruce concerning the importance of electrical discharges in the cosmos, and in particular in the sun's atmosphere. Bruce agrees that the sun offers his ideas perhaps their greatest challenge because of the very high electrical conductivity of the solar material at all levels. Any electrical discharge in the sun's atmosphere demands an exceptionally rapid and strong means of generating differences in electric potential. End of quote. Here we see a recognised leader in the field who at the end allowed that the sun itself as an isolated body in space might somehow generate its own electricity. But today, scientists don't know how the Earth can generate its own lightning. And that may surprise you, but one of the experts, Dr. Newman, or Professor Newman, who's written on this subject, it's been his subject lifelong, has admitted that we still do not understand what causes lightning, what actually causes that electrical separation sufficient to initiate a lightning discharge on the Earth, let alone on the sun. All we have is a cover story, one of a large and growing list. Of course, you've all heard about the updrafts of ice particles and so on separating electricity. It doesn't work. In fact, some years ago, I wrote on my website, the balloon goes up over lightning, and this was where high-altitude balloons were flown above thunderstorms, and the surprise that came from that was that the electric field the charge is already there, it's waiting to discharge through the cloud. It doesn't have to be generated in the cloud. So the source of the lightning is external. And of course, since then we've seen sprites and elves and all of the other magical things that occur above powerful thunderstorms, rising to the ionosphere, and from the ionosphere to the magnetosphere, and from the magnetosphere we already have these so-called flux ropes, which are electric currents, to the sun. So our weather is driven largely electrically, and this is something that climate scientists know nothing about. Whoops. Now here's the guy who made the most advance in the understanding of the electrical nature of the sun, Ralph Jurgens. An important outsider, an engineer and a pioneer of the electrical model of stars, he was inspired by Bruce and also Birkeland. But because of the tunnel vision of the consensus view, he was forced to publish his ideas in obscure journals in the early 1970s. His model is a shining example of common sense and simplicity when compared with the infernally complex and improbable thermonuclear paradigm. One of the problems with the thermonuclear paradigm is that it took a lot of ingenuity to figure out how you might have a thermonuclear cycle which would work inside a star. Even then you required incredible pressures and temperatures. But what's more, some of those reactions, one in particular, the reaction rate varies as the temperature to the 5th power. Well, that is highly unstable. That's why they make hydrogen bombs. It's because it's highly unstable. And one of the other reactions requires quantum tunneling. So there are all sorts of assumptions piled upon assumptions to actually end up with that so-called wonderful thermonuclear model of how a star works. Jurgens' model is simplicity. Yet Jurgens' insight was in danger of being lost following his untimely death in 1979. In fact, it was within weeks of Velikovsky's death, which was ironic. Ralph wrote, "As I pursued the phenomenology of electric discharges, it gradually dawned on me that, structurally, the atmosphere of the sun bears a striking resemblance to the low-pressure type of electric discharge known as the glow discharge." And when you look at the sun in that way, you can understand how easy it is to describe what you see on the surface of the sun in electrical terms. The sun's surface is carpeted with complex magnetic fields. At whatever fine structure they go down to, they can see more and more levels of structure in this magnetic carpet. Now, as all electrical engineers know, only electricity or electric currents can produce magnetic fields. So what we're looking at is a seething storm of electric currents. So the sun must be understood in terms of electric circuits, because you cannot, all currents must flow in a circuit. And the questions then are, where are these circuits and what creates them? Well, Hans Alfvén paved the way by drawing a circuit for the sun, but he assumed that the sun was the driver of that circuit and it was closed. So you had the current flowing out along the equatorial plane of the sun, the so-called solar wind, and then somewhere at some distance, he said, it curls back and it comes in at the poles. So he drew the circuit, but he assumed the sun was the driver, without explaining precisely how that might work. And having established the circuit, of course, that radiates energy, electromagnetic energy and so on, and the sun is obviously radiating energy, so what sustains these currents? Sorry, I didn't flick through those. So there's the summary of just what I've said. And here is the sun in that solar circuit. Remember I said there's a current flowing out here. This is the solar wind, and it comes in at the poles. This diagram is from Don Scott's book, The Electric Sky, and I recommend that book for anyone who wants to go into the electrical theory of how this might work. The beauty of this relatively simple diagram is that it shows how you can explain the solar cycle. It's simple. You don't have to rely on unseen things going on inside the sun. All of this is happening at the very top of the atmosphere of the sun, which is very highly conductive, of course, and can carry these currents. So, the greatest puzzle of the sun, its magnetic field reversals, is solved. The sun is subject to a varying DC, or direct current, power input, and so generates alternating magnetic fields, because the magnetic field always tries to oppose a change in the current. It's rather like a power transformer, but one that's operating with a steady current through it with a varying input superimposed. And this makes some kind of sense, because these Birkeland currents, as Don showed last night, can have waves passing through them to cause pinches and so on. So they're a part of a circuit. It has a resonance. So I would suggest the 11 or 22-year solar cycle, sunspot cycle, is driven by the resonances in the sun's circuit. Other stars have different resonances, and so their stellar cycles would be different. So I refer you to Don Scott's book. This diagram is on page 112 and explained more fully. I'll mention again that the polar current flow shown is referred to by Hans Alfvén, but he considered the sun as a generator in a closed circuit and not as a load in a galactic circuit. So the principal difference in the electric universe model is that the circuit extends beyond the heliosphere, and this has been confirmed by surprising discoveries by the Voyager spacecraft at the boundary of the sun's interface with interstellar space, and the IBEX mission, which has picked up, as Don explained last night, the signals we would expect from an enveloping Birkeland current pinch around the sun. As for what creates and sustains the circuits, I will address that in my presentation on electric universe cosmology, which I think is tomorrow. Now, you've seen this picture before. As we said, this is an archetype for a stellar circuit where we can actually see it in glow mode. This particular object, M2-9, is 2,100 light years distant. And as Don said last night, most stellar circuits operate in a more diffuse plasma environment, a lower current density, so that the circuit does not glow. But you can imagine all stars have this kind of plasma circuit impinging on them. The conventional caption for this image says M2-9 represents the spectacular last gasp of a binary star system at the nebula's centre. They require a binary star system for one star to rip material off the other to produce that disk of dust and gas that Don explained last night is necessary in their models, whether it's a black hole or a star or whatever. Such a disk can successfully account for the jet exhaust-like appearance of M2-9. I don't think so. The last statement is patently false. The detailed structure of planetary nebulae has defied all attempts at explanation by flinging gas out of a star. On the contrary, the structure conforms to the concentric pinched cylinders of an interstellar current filament. More on that in a moment. Don also showed a stylized version of this object. It's called the Red Square Nebula, and it's a celestial object located in the area of the sky occupied by star MWC 922 in the constellation Serpens. And the quote here is from Peter Tuthill of the University of Sydney, who was the people, his team actually discovered this thing and imaged it. The thing that really takes your breath away is the astonishing degree of symmetry within the intricate linear form. A series of rungs and conical surfaces lie nested, one within the next, down to the heart of the system, where the hyperbolic bicone surfaces are crossed by a dark lane running across the principal axis. This, of course, is once again your dust lane, which is hiding what's going on inside. Then Tuthill makes the connection, and this is important. It is fascinating to take a second look at one of the most famous astronomical images of them all, supernova 1987A. And that was also mentioned last night by Don, and I'll talk more about that. This particular object, the Red Square Nebula, is 34 times closer than supernova 1987A, so we see fine detail in the inner structure of the stellar circuit. Tuthill goes on to say, it's the best astrophysical laboratory yet discovered for studying the physics of generating the mysterious sharp polar ring systems like that around supernova 1987A. And he goes on, a system as complex and fascinating as this is bound to keep us guessing for years to come. How did this beautiful, crisp structure form, he asks. This is the million-dollar question. Well, I'd like the $1 million, thank you, because I explained it. I explained it in a peer-reviewed paper to the IEEE, and it is based, as Don explained last night, on Birkeland current filaments impinging on a star. What you're seeing there, these are double layers, seen edge on. The Birkeland current filaments, you can actually see the filaments themselves in the original image. They're maybe a little hard to see here, but you can just see this hairy look here. And this is the pinch coming in here. It's quite a fantastic image, and I'm really pleased that it's been discovered and is being examined in detail, because this is important. So let's move on. This is the supernova 1987A, and the clue for this came from Tony Peratt's work. And on the far left there you see the stellar Z-pinch, and this is one of his diagrams, a simulation. And then right at this, in the neck of the Z-pinch, this is the detail you see here. These filaments coming down here strike the material which is in the solar wind, if you like, the stellar wind, which comes out in the equatorial region. And let me see. I'll just catch up with my notes here. The bright ring of beads there are due to the current filaments lighting up the equatorial stellar wind like a ring of searchlights through a thin cloud. One of the interesting things is I mentioned in the article that I wrote for the IEEE Plasma Sciences Journal that these beads, Tony said, they tend to pair up so that over time they coalesce and they become fewer in number, but they have certain classical stabilities where you get a particular number of these things. 56 was one of the classical ones. I can't remember whether this quite gets to that, or might be 28, where they've tended to pair. But I suggested that rather than being a result of an explosion or light catching up with something that was left by a prior ejection of material, which is the ad hoc astronomical story, these would remain relatively stationary because they are actually the pinch itself, so they're not going to move very far. But these filaments twisting around one another will pair up and so on, so I'd say they would rotate. And this is the kind of research that anyone who's interested could take up and publish a paper on. The more distant coaxial rings, you'll notice over on the right here, there are more distant ones. These are just double layers further along the pinch. And notice they're symmetric because the pinch is symmetric. And it's always a sharp boundary, as we saw with that red square. Those double layers form a very thin layer, and this is why it's so remarkable for astronomers. How do you form such delicate structures if this is all due to material blowing out of a star? Okay. So we come to the sun's environment, and Don dealt with this, but it's worth talking about again. And it was published, this picture was published in May 10, 2012. New IBEX data show heliosphere's long theorised bow shock does not exist, was the quote from that article. I had written on my website in November the 13th, 2005, almost 7 years earlier, the solar plasma and that of interstellar space are two different plasmas, which must therefore have a double layer or Langmuir plasma sheath between them. So to treat the heliospheric boundary simply as a magnetohydrodynamic shock problem is naive. The heliosphere is the boundary of the sun's electrical influence. That's where the sun's presence in the galaxy meets the interstellar regions of the Milky Way. So the heliosphere is the boundary of the sun's electrical influence. And Jurgen said most of the sun's driving voltage appears across this plasma sheath simply because of these graphs here, which show the relationship of a normal plasma discharge tube. So this is in the laboratory. These are the curves you find in the laboratory. And if you apply that to the sun, here's the sun, the positive electrode. Come down here, there's the sun. As you move out from the sun, you'll notice that there's only a very shallow voltage change. And this is important because one of the arguments against our work has been if the sun is electrical, there should be all these relativistic electrons and particles streaming past the Earth. No, not at all. The voltage difference is very slight, such that it's just enough to cause the electrons to drift towards the positive anode, and in the opposite direction for the solar wind to be accelerated rapidly close to the sun, and then it just continues accelerating very slowly out towards the heliosphere until it hits this bump. And I predicted before the event that the solar wind would slow down more than expected before it got to the boundary, and that was found to be so. There were articles saying there was no explanation for why the solar wind should have suddenly stopped. Well, that's the answer. It's an electrical discharge. So I'll just repeat. If you refer to Jurgen's original work, you will see that he invokes a very large voltage driving the sun. But he was assuming that all of the sun's radiant output must be accounted for by the electrical power input. But we have the evidence that nuclear fusion is taking place at the sun because we've got neutrino images now. I don't know whether you saw it some months ago. There was a picture published which showed this glow, circular glow in the sky. It was rather pixelated because it's not very good definition. And right in the centre was a little circle, and that's where the sun is. So the neutrino telescope, if you like to call it that, is very low definition. So you cannot tell whether the neutrinos are coming from the core of the sun or from the surface of the sun. It's unable to distinguish. So what I'm saying is that the electrical power required to catalyse photospheric nuclear fusion is yet to be determined. But the electric universe model says that stars, all stars, create the heavy elements in their photospheres. It's all happening right in front of our eyes. You don't have to postulate any crazy things or crazy conditions inside a star. It's all happening right in front of you. And that makes sense. I mean, nature always does things the easy way. And if that's the easiest way, and I'm sure it is, then that's the way we should be looking at it. Okay, I think I've covered all of that. Now we come to the plasma focus. This is something that Eric Lerner and his, is it Lawrenceville Nuclear Labs or something or other, he's actually producing fusion or using one of these devices. The important thing to notice is that what you have is two coaxial conductors. And if you think about it, these stellar circuits have concentric conducting plasma layers. And when it comes down to a pinch, there's the possibility that you'll get a kind of short circuit across the between those layers. So this is important. It's also important in the sun's photosphere. What happens is that this little red thing here represents a capacitor bank where you store an enormous amount of energy which can be released extremely quickly in millionths of a second. You have a special high-speed switch here. This yellow part here is your inner metal electrode, so that's your inner conductor. You have insulators then between that and the outer conductor. You close this gap and all of a sudden there's an electrical discharge between the inner and the outer pipe, tube. The discharge doesn't stay still though, it doesn't just go from here to here, it moves by electromagnetic forces down the barrel, and when it gets here it balloons out and then folds back in and forms a tiny little plasmoid. And you can have the energy of a whole room full of capacitors, which can be an enormous amount of power, released into this plasmoid. Here we go, this will show you what it does. Do we have sound?
These filaments are little whirlwinds of plasma. The sheath of filaments converges together into a dense pinch or focus, combining all the filaments into one. This filament kinks and twists itself into a tiny dense ball only a few thousandths of an inch across, called a plasmoid. Instability in a plasmoid creates powerful beams in opposite directions. Positively charged nuclei flow in one direction, and electrons flow in the other.
That's it. Notice it was thousandths of an inch. So you've got the energy stored, an enormous amount of energy in a very tiny volume. And where do we see that? We see it in the centres of galaxies. We see it in blazars, any of these very highly concentrated point sources of radiation. One other aspect of these devices that I should mention is that it's not only X-rays and particles that come out of the beam, it's also the most copious source known in the laboratory of neutrons. And neutrons are very important when you want to create the heavy elements, because you need a supply of neutrons to add to the nuclei, which can then beta decay and whatnot, and give you all the various elements up the table, up the chemical element table, and the isotopes as well. And it's significant, of course, that in the solar spectrum you see the heavy elements, very highly ionised, possibly because they've only just been generated, I should say. You can't create matter. So we go back to our beautiful M2-9. I've just put the little plasma focus down the bottom here as a reminder. Here you have your concentric cylinders. And if there is a breakdown between the central column, which, you remember there's a central column of current. So if you have a breakdown between the inner cylinder and this central column, you will tend to form a plasma focus effect. And these flyers have some of that shape. You can see that this kind of curved shape. And they're a real anomaly. There's no explanation for them. So a distinctive feature of this nebula are the two bright patches on either side, which are known as flyers, or fast low ionisation emission regions. They appear to be relatively young, moving outwards at supersonic speeds. According to Bruce Balick, University of Washington, some of their observed characteristics suggest that they are like sparks flung outward from the central star late in the very recent past. That's not a very good... It doesn't explain anything. Yet their shapes seem to suggest that they are stationary and that material ejected from the star flows past them, scraping gas from their surfaces. Well, there's nothing to do with scraping gases and that, and this is under electromagnetic control, so it's not a mechanical blast effect or anything like that. In either case, the formation of flyers cannot be easily explained by any models of stellar evolution. I'll just see if I've missed anything. Oh yes. An interesting side issue is that this might also explain the asynchronous reversal of the solar magnetic field. You know, when the sun's magnetic field flips, it often does it in one hemisphere and not the other. And then later the second hemisphere switches. If the solar cycle is driven by a regular disturbance travelling along the interstellar circuit, then one of these dense plasma focus effects will be affected before the other. But as you can see, the complexity of a star's circuitry will require a lot more research. Birkeland wrote with his unusual prescience in the Norwegian Aurora Polaris expedition in 1902-3, it might be imagined that the interior of the sun formed the positive pole for enormous electric currents. This was Jurgen's conclusion also. This assumption has the advantage of appearing to give a natural explanation of the movement of the sunspots in various latitudes, he wrote, which he demonstrated with his Torella experiments. This guy was a great experimentalist. In this case, the origin of the sunspots must be that the presumptive, more or less insulating photospheric envelope was sometimes pierced by disruptive discharges, thus forming great electric arcs. This is the position of the electric universe model. Because you've got this plasma storage ring. This is the SOHO NASA spacecraft. And in ultraviolet light, you can see there's a plasma torus around the sun. Now, the energy stored in there can reach a point where it discharges to the surface of the sun. And depending upon the voltage differences, it will shift in latitude. Those discharges will shift in latitude, which is exactly what sunspots do. So here's this guy back in 1902, 1903. He had it practically figured out. Nobody was listening, especially not Sidney Chapman. Sunspots, and these are very interesting. The sunspot penumbra shows the detailed structure and behaviour that has nothing to do with turbulent hot gas. It has nothing to do with convection. And recent discovery by those people looking at the seismic activity or what's going on underneath the photosphere have shown that there is practically no convection. So the standard solar model has already been discredited again by this recent discovery. The sunspot is dark, showing the sun is cooler beneath, and so the bright sun is a photospheric effect alone. One of the things about Birkeland currents is that it induces rotation. So the problem of why do galaxies spin, why do stars spin, why do planets orbit stars and so on is easily solved. It's driven electromagnetically. Super tornadoes have been discovered in the chromosphere between the corona and the photosphere. It is estimated there are more than 10,000 of them continuously present in the quiet sun. Surface and coronal vortices are connected. Rotation is a natural effect of Birkeland currents. So what I'm suggesting here is that the penumbral filaments are actually electrical tornadoes. It's like a tornadic form of lightning. And a tornado is a slow discharge. It's like slow lightning. So what you're seeing here on the sun is a form of slow lightning. The sun is a ball of slow lightning. They have bright edges, dark cores. That's because on the right is a special effects thing where you've got a helicopter blade rotating above and you put fuel into a fire at the base and it forms this twisting vortex. And the centre, looking through it, is darker than the edges, and this is precisely what you see on the sun. So they are tornadoes. It's the ideal site for nuclear fusion and heavy element synthesis by neutron capture because the electromagnetic forces, pinch forces and so on, that are active in those stellar tornadoes are enormous, and it's a place where the particles required for nucleosynthesis are available. They're not going anywhere soon. These are actually drawn-out versions of anode tufts. Just a moment. Bright plasma tufts form as a secondary plasma in the primary plasma of the discharge. The number of tufts increases with increasing current density, and the tufts float about above the anode and are hotter than the anode. This is why this photosphere is bright and it's darker underneath. They space themselves apart evenly over the anode surface, and penumbral filaments have the features that may be expected of anode tufts in a gravitationally stratified atmosphere. Rather like the Earth, we get tornadoes, it gets bigger ones. The electric photosphere, this is a diagram that was based on Jurgen's work, and Don Scott noticed that this curve has the shape of a transistor. And the beauty of this is that a small change in voltage here, because what happens is the positive particles in the sun, any that have sufficient energy and get into here, are free to move about, and any that get over to this side here will suddenly reach the edge of this waterfall effect and be accelerated to form the corona. I have to go through this fairly quickly because I'm running out of time. This is the tuft area. These are those electric tornadoes. This is where all the nucleosynthesis is taking place, I think. Just a small change in voltage here raises the barrier for these particles escaping from the sun, so it's a very good control barrier. This is why the sun, its radiant output remains steady to within about 0.1%, while the X-ray output of the sun varies markedly. The sun is a variable star in X-rays, and the X-rays are a good indication of the electrical power that's being expended in a small area. So the tufted sheath forms a barrier for protons escaping the sun, and the spicules, which are these little jets that occur between them, provide electrons to stabilise the sheath, just like the porous anodes used in some arc lamps. There is no explanation for spicules in the standard model. So, summarising, Electrical energy arrives at the Sun from dark mode galactic current filaments. The electric discharge intensifies close to the Sun, causing the thin atmosphere of the corona to appear to be heated to millions of degrees. The heavy element body of the Sun is cool and of unknown structure and composition, and I will address these questions in a later talk on electric universe cosmology. So, we cannot understand the countless stars in the heavens until we understand the Sun. All bright stars produce heavy elements in their photospheres. The incredibly complex evolutionary story of stars to fit the Hertzsprung-Russell plot is invalid. We do not know the age of the universe or any celestial object in it. We have been blinded by the story of the Sun concocted a century ago by scientists who had no grasp of the complexities of plasma behaviour. They were driven by a need to extend the theoretical lifespan of the Sun to accommodate the needs of the geologists' lengthening timescales. So it's understandable that the discovery of nuclear energy was embraced at that time as the only possible answer, no matter that it was entirely unpredictive. Ironically, the astrophysicists were, and still are, unaware that the geologists' Earth history is a fabrication too. I will address that story in my next presentation. So, in a sense, Eddington was right. The Sun is a simple thing, far simpler than he imagined. It is the electric universe environment that is complex, but that complexity arises from a few simple concepts and repeated fractal patterns. Nature is like that. Meanwhile, for those trying to produce fusion power like the Sun, it's high time to move on and find out how the Sun really does it. Nature never does anything the hard way. Thank you.